All right, welcome to the third and hopefully final video for Unit 1, Lesson 3. Let's get started. We left off with example 1, number 3. Okay, let's put this into equation form. All right, keep in mind that's the same thing as saying the function of I have a negative x, and that's a positive 4. Okay, that's not a minus 4 because there's a minus in between them, and then plus 1. If I put that into my function, then the parentheses will stay in the function. So it's the square root of negative x plus 4, and then I have my plus 1 afterward. There you go. So now I'm going to take my original graph, which goes here, 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 and here. Good. Goes like that. That's the square root of x. I'm going to apply the following transformations. And if you remember, earlier in the notes, we talked about our order of transformations, which I have here. Okay? PEMDAS, we do our left or right movement first. Then we flip anything if we need to, or stretch or compress. Then we move our up and down. Okay, so let's take that and apply it here. So my left or right tells me I'm going to move left 4 right there. Left 4. Then this tells me I'm going to flip. I'm going to flip that not over the x-axis, but over the y-axis because I'm negating just the x. I'm not negating everything. Okay? So then I'm going to reflect over the y-axis. Then I'm going to move up 1. Okay? So first I'm going to do is move left 4. So this point here, so where do you move left 4? 1, 2, 3. It will be right here. The next one will be right here. The next one will be right here. And the next one will be right here. Those are my 4 points. They're all moving left 4. Now, I need to take each one of those points and reflect it over the y-axis. So this point right here is going to reflect 1, 2, 3, 4. 1, 2, 3, 4 right here. This point here is going to go 1, 2, 3 spots. 1, 2, 3 spots. This point here is going to stay on the y-axis. And this last point here is going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now I have these dots right here, and I'll do this in yellow. After the reflection, here's where it starts. Goes to this one, goes to this one, and goes to this one. Okay? And last but not least, all of those yellow dots need to move up 1. We'll do that purple. So this dot moves up 1. 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 So, in all reality, that's the square root of, like I say, 4 minus x again, plus 1 on the outside. Of course, these little green and red little dots that do my movement, you don't want to show those on a graph. You don't want to show those at points or coordinates, but I'm just showing you how the movements are occurring. All you really need is the blue graph that we originally drew and that purple one that I drew after. All right? Okay, let's take a look at some problems we have here with A and B, for example, 2. Okay, and that looks like it on this slide. All right, we're going to describe the transformations to take f of x and g of x. So how does this, the absolute value, which is a v, become this right here? All right, if you want to try and do this on your own, you pause it, you know how this works, do it, because I'm about to do it right now. First thing is I need to worry about left or right movements. That's this bad boy right here. That tells me I'm going to move right 2. That's the first thing I do. Second thing I worry about, I mean flipping or stretching and compressing. That's this right here, okay? I'm negating the whole thing, not just the x, because that negative is going to get distributed, all right? So that tells me I'm going to not only flip, I should say reflect. Reflect, that's an R, over the x-axis and that 3 tells me that there is a stretch by a factor of 3. Stretch by a factor of 3. And lastly is my up or down movement. It's up 4. All right? So let's take a look at the next one, okay? I don't make x cubed, which it looks like this, goes down, all right? Still look like this, all right? Let's do this in proper order. We are going to worry about left and right first, which is this number right here. That tells me I'm going to move left 7 units. All right? Next is this. It's a stretch. In this case, it's a compress. We're going to compress by a factor, and I'll write factor, I did it before, by a factor of 1/2. Okay? And last but not least, the up and downs. This right here tells me I move down 9 units. Pretty simple. These are, it's nice when we don't have to graph them, we just look at them. But even if you have to graph them, this is the process that goes through your mind first, then you do it. All right, let's take a look at example 3. Okay? And we're going to take this graph we have here. I don't know, it's like some sort of slanted M. All right? Some M that's just given up and it's about to just collapse. And we're going to graph 3 different transformations of this graph, which we're going to call f of x. Okay? In blue, I'm only going to do the negation of the function. In red, I'm going to do x plus 2 on the inside. Then in green, I am going to subtract 3 on the outside. So first, let's identify what these transformations are. This one right here tells me, well, I'm not negating the x on the inside, I'm negating the whole thing. So I'm going to reflect over the x axis. Okay? So I'm going to take this, it looks like there's a point here, I'm going to reflect it over the x axis to here. There's a point here, okay, I'm going to reflect that 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Reflect this point, it's 2, 1, 2. Reflect this point, it looks like 4 up, 1, 2, 3, 4, yes, 1, 2, 3, 4 down. And this point looks like it's right on, we'll keep that, so bang, 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 bang. That, my friends, is a reflection, sorry about that, is a reflection of our graph over the x-axis. Here's the x-axis. Now in red, I am adding or subtracting inside the function. So that means a horizontal movement. So this tells me I'm going to take my original function and I'm just going to move left by 2 spots. So each point, this one here is going to move left, 1, 2. This point here is going to move left, 1, 2. This point here, left, 1, 2. You get the idea, 1, 2. 1, 2. And I do this. And let me see if I can get rid of all these little dots here without, yeah, that's stars. We go up, down, up, down. That is my black graph, the original one, moving left 2. That's cool. Now this one right here. If I'm subtracting outside the function, that's a vertical movement. This tells me that I'm moving down 3. So I'm going to take all these points and move them down 3. This first one's going to go 1, 2, 3, down right here. This one here is going to go 3, 1, 2, 3, right there. This one here is going to go 3, 1, 1, 2, 3, right to here. It's going to be 1, 2, 3, right there. It's going to be 3, 1, 2, 3, there. And we get some sort of mayhem. But that's correct. That's absolutely right. When you don't have different colors, it's hard to see everything. This looks like a blur. If you're doing all pencil or all pen, I was trying to tell my class to try and bring different color markers, especially for graphing things. Or 3 different colored pencils or whatever, especially blue, red, and green. But I know sometimes you don't, and you don't have it, that's fine. So there you go. On to example 4. And f of x equals x squared plus 3x plus 2. Write the equation for each of the following transformations. All right, this just works out to be basic algebra. Okay, you're just going to be able to manipulate what they're telling you to do. We've talked about substitution in functions, right? If I take f of negative x, I'm going to put negative x in for each of these x's. And what I like to do is I put parentheses for each x that I'm substituting in for. Okay, I'm putting a negative x here, and a negative x here. All right? So if I were to rewrite that, negative x squared, well, that just gives me x squared. 3 times negative x is negative 3x. And then I still have this plus 2. That's all that is. They want you to rewrite the equation? We just did. All right? Now, what happens when I throw a 2x in? Well, I still have my original function. It's x squared plus, that's 3x, so 3 times whatever x is, plus 2. I've got to put a 2x in each one of those, okay? Well, 2x squared, I've got to square both the 2 and the x. The parentheses are important here. Some people say, okay, well, I'm just putting 2x in for this first x, and I square it. Okay, that's 2x squared. No, you need to square everything that's being substituted in there. You need to square the x, and you need to square the 2. Okay? Plus, well, 3 times 2x is 6x, and then I still have my plus 2. There you go. See? Basic algebra. Now, for some reason, this throws a lot of my students off. But if you do things the way I tell you to do things, or the way that I'm modeling them for you, it takes out any uncertainty. Let me explain. Again, wherever there's an x, I'm putting parentheses. So it's x squared plus 3 times x, okay, plus 2. All I'm doing, just like here, I threw a negative x in. Just like here, I threw a 2x in. I'm throwing an x minus 1 in. All right? Now, here's something that drives me crazy. A lot of students do this. X minus 1 squared is not x squared minus 1 squared. No, stop. When I square something, I need to multiply it by itself, which means I'm going to have to FOIL, or sometimes you do the box method, right, where you do x minus 1, and you multiply them out and combine like terms. I like to FOIL, meaning x times x is x squared. X times negative 1 is negative 1x. We have an x times another negative 1, again, is negative 1x. Negative 1 times negative 1, positive 1. The only thing I can combine is that right there. So x squared minus 2x plus 1. This right here is what this is equal to. So for this, when I FOIL and expand it out, I can make x squared minus 2x plus 1. All right, that's the first step. Now I need to distribute my 3. That's plus 3 times x is 3x. And then 3 times negative 1 is negative 3. And I can't forget I still have a plus 2 here. The only thing that was difficult about that was you had to remember to FOIL this. Because plugging it in was easy. Okay, now you have to FOIL this. Now all you're doing is combining like terms. This is not crazy. So what do we have? We have one x squared term. I have negative 2x plus 3x. Okay, so that's going to be a plus 1x. If I have 1 plus 2, that gives me 3. But now I have to subtract 3, so they will cancel out. 3, I take away 2 and 1, which is another 3. That's your answer right there. Example 5, and I like these types of problems because I don't have to graph it. I just got to show my knowledge of what numbers tell me what movements. That's it, all right? So, if f of x equals x, okay, that's my original function, write the equation of g of x that has a vertical stretch by a factor of 10, a reflection over the y-axis, okay, a horizontal shift of 6 to the left. That's important, I gotta know which direction, and a vertical shift down 3. So, I know for a fact, here's x, this is what I'm starting with. We always start with our horizontal shift, right? That's inside the parentheses. My horizontal shift, 6 to the left. That means I need to add 6 inside the parentheses, right? Next, I do any, okay, so I did this in blue. I do any vertical stretches and reflections next. Vertical stretch of a factor of 10. That means I know I'm multiplying this by 10. All right? The next one I'll do in purple. If I am reflecting over the y-axis, I'm not negating the whole thing. I'm just negating the x. There it is. Done. And last but not least, okay, I need to do a vertical shift down 3. That means outside of all this, I am going down 3. So I subtract 3. And what I want to do is, because they want me to say as g of x, I want to write an equation. The equation needs an equal sign. That was cool, y'all. You see what we can do when we know our rules about transformations? All right, the last thing we're going to do here, and I don't want to, let me rephrase that. I want to introduce this to you because you might start seeing things like this. Okay, this has nothing to do with transformations. It's a type of graph that you might see. I mean, you might have seen them in Algebra 1, but I want to kind of refresh your memory. If you did, if you haven't, hey, this is a piecewise function. All right, a piecewise function. So here it is, this whole mess right here. Okay, this is the whole function f of x. It's all 3 of those lines. Now, here's what we need to do here first. Realize that these are the equations we're going to graph. All right, and these are telling me where we're going to graph them on our grid. Let me explain, okay? Let me explain. You see the top one right here, negative x minus 8. That is going to be graphed when x is negative 3 to negative 9. Here's when x, okay, here's our x-axis. Here's where x is negative 3, and here's where x is negative 9. From these two spots, you don't have to draw this. I'm just trying to give you a visualization. In between these two lines, I'm going to graph negative x minus 8. All right? How do I do that? I need to plug in these numbers and plot some points and draw that line. So let's start with negative 3. Now, I'm going to negate whatever x value I have. So that's like saying the negation of negative 3 minus 8. That would be positive 3 minus 8. That's negative 5. So when x is negative 3, I put a dot at negative 5. And if we keep on doing this, okay, let's see what happens. If I put a negative 4 in for x, that would turn into a positive 4. Positive 4 minus 8 will give me negative 4. So when x is negative 4, y is negative 4. Let's see when x is negative 5. Okay? If I negate a negative 5, that's like saying a positive 5 minus 8, that would bring me to negative 3. So when x is negative 5, y is negative 3. And you can see a pattern. Okay, this is just going to keep on going up and up and up. And I stop right there. How come? Because I am now in between the x interval of negative 3 to negative 9. If I connect this, that represents negative x minus 8 from negative 9 to negative 3. Okay? And let's take a look at the way it was given to us. They want us to graph this, which we did, on this interval, which we've done. So, if I do this here, boop, and I do this here, boop, and I do this here, and I do this here. Now it looks nice and clean. All right? Now let's do the next one, obviously in a different color. Red. From negative 3 to positive 3. Okay, from negative 3 in the x value to positive 3. So again, do not draw these dashed lines. I'm just giving you a visual. From here, they're not asymptotes, they're not anything, they're just to give you a visual. In between this area of the graph, which they tell us, they want us to graph this right here. All right? And again, how do I know where the points go? Well, I can graph this in the calculator and look at when x on the table, when x is 3 to negative 3. Or I can just calculate them out. In fact, why don't we do that right now? We're going from negative 3, negative 2, negative 1, 0, 1, 2, and look at me, I ran out of space, 3. I negate my x, I square my x, I negate it, and I add 4. That would be 4. If I take negative 3 and square it, I get 9. If I negate that, I get negative 9. And if I add 4, that's negative 5. So my point is negative 3, negative 5. Look at that. It continues. That's nice. If I square negative 2, I get 4. If I negate that, that becomes negative 4 plus 4. That's 0. So at negative 2, that's 0. At negative 1, okay, that'll be minus 1 plus, that'll be 3. So negative 1 comes up to 3. At 0, that's 4. So at 0, we go up to 4. And it's a parabola. So you're going to start to see here, here, and back to here. It's a parabola. That's what a parabola looks like. Now, no, I'm not going to be able to get rid of all those dashes. Dang me. There you go. I have now just graphed. Ooh, I did that in red. I have now graphed this part of the parabola from negative 3 to 3. You see that? It's like two different equations. They're just in different intervals. Now, let's take a look at the last one. I'm going to graph y equals x. Whatever x is, that's what y is. Okay? That's our identity function. From 3 to 7. Okay, so we're going to go from 3 to 7. Again, you don't have to do this. I'm giving you a visual, and so forth. In between that area, with the two dashed lines, I'm going to graph the equation y equals x. So, when x is 3, y is 3. So at 3, 3. When x is 4, y is 4. When x is 5, y is 5. When x is 6, y is 6. When x is 7, y is 7. Boom. Get rid of these dashed lines. All right. Now, one thing I want to point out to you. There is no equal sign right here. You see that? That does not include 3. Everything else we've done has included 3. All right? Everything else we've done has included 3. This included 3. That's included negative 3. They're all equal. This does not. Okay? So for my green graph, right where x is 3, I don't want to include it. So instead of putting a point, I put an empty hole. Okay? That means if I want to know the value of my function when x is 3, it is not here. That's an empty hole. It is this value. All right? That's a critical thing because the next question is asking us, is this a function? Does this pass the vertical line test? In my mind, vertical line test, this is supposed to be considered one function now. This isn't 3 separate ones. We had to draw 3 separate ones to create this one function f of x. If I put this line anywhere, does it touch the graph more than once? It does not over here. Once. But what about at -3 where the blue and the red dot combine? Guess what? If I were to draw this as one graph, I would go here, here, stop, pick up my pencil. This is a whole thing. So that's one thing. So no, that's not 2 different things right at the point down here. Okay, that's still one. It's touching it once. What about at 3? It looks like it touches twice, doesn't it? It does not. That's why it's important that you know this is a whole. The graph does not exist right at 3 up here. It exists at 3 down here. That's the significant point about the whole. So this only touches once. No, it does not touch here. That's a whole. Yes, it does touch here because that is an actual coordinate point. It is not a whole. So as I move off 3, boom, yeah, I'm not touching down here where it used to be red anymore. I'm touching green. That is indeed a function. It is a function, yes. How come? Explain. It passes the vertical line test. Mwah, We are evil. We know math so good. And that's a good thing. Especially with Halloween coming up because it is, September is almost done. So there you go. We are done with Unit 1, Lesson 3. Thank goodness. Oh, graphing is just so much. Just graph. I like just plugging in numbers and calculating. I don't like graphing. I mean, I do, but it's a different type of math. Okay? So good luck, and I will see you hopefully, or you will be hearing me for Unit 1, Lesson 4 sometime very soon.